you very much. Certainly appreciate everybody's attendance and active participation. We're going to get our program underway this afternoon. It's going to be quite exciting to hear what's happening with Stena Germanica and other very exciting methanol applications. In preparing to introduce Per Stefenson, I had to consult a higher authority, and so I thought of the story of Jonah, or even maybe I should say the Ark, Noah's Ark. And the reason I mentioned Jonah's Ark, or the Noah's Ark, is because a famous man once said that predicting rain does not count, building arks does. And he operates a world-class fleet of vessels and arks, and I think his Methanol Germanica represents one of the key milestones for the evolution of the technology and application of sustainable transportation. So with that, I'd like to introduce my friend and colleague Per Stefenson. He's a naval architect. He's a marine standards advisor for Stena. He has diverse expertise and deep expertise in standards, regulations, project management, engine design. He's been at Stena for a number of years. He's also been with the Swedish Maritime Administration and also with the Royal Swedish Navy. So with that, we're really honored to have our friend Per join us. Thank you, Per.
Thank you very much. Thank you very much for inviting me here. Yes, I'm Per Stefenson. I'm working at Stena, which is a shipping company in Sweden. For many people, they think that Stena is only Stena Line, which is the ferry company. But actually, we are also involved in quite a large tanker fleet, about 100 tank ships that is all around the world. And we also are involved in Stena Ro-Ro, which is about 30 Ro-Ro ships, and as well as some drill ships, actually, helping for drilling for oil and gas, also worldwide. So it's altogether it's quite a big company with a turnaround for about, let's see now in currency, about 5 billion euro, something like that. So, why am I standing here, and why are we talking about this with methanol and so on? Well, this is actually the big challenge. This is why we started to look into this. And this is the map of the SECA area, the sulfur emission control area, which is in the Baltic Sea, and as you can see also in the North Sea and the British Channel. And the red lines you can see here, that is actually Stena Line's ferry lines. So we operate about 40 ships in 22 different lines. It should be 22 if you're counting the lines there. And you can see that it's only in the Irish Sea that we are not within the SECA area. Why the Irish Sea is not a SECA area, I don't know. But this is the way it looks anyhow. And the SECA, the sulfur control area, what does that mean? Well, that meant actually that we had to go from 1% sulfur in our fuel or in the exhaust gases and down to 0.1%. And to do that, we had some different possibilities. One was, and the one that most ships have done, is just to shift over from heavy fuel oil with 1% sulfur to low sulfur marine diesel oil or marine gas oil with 0.1%. At the time when this was decided, and also when it was coming towards us in like 2012 or so, the oil price was for the marine gas oil, it was $1,050 per ton, and the heavy fuel oil was about $600 per ton. So there was a large, about 40% difference between the marine gas oil and the heavy fuel oil. As things have turned out right now, I mean, we are in a completely different situation right now. Today, the marine gas oil costs about $250 per ton, and the heavy fuel oil costs below $100 per ton. But I mean, everybody, most people anyhow, thinks that this is not here to stay. This will change. How quickly, we don't know. But we are looking, and we have the good thing in our company is that it's private owned, so we don't have to make profit every quarter. We can have a little more long-sighted views and so on, and our owner had decided that the methanol idea, that is, we are going to continue with that, even if it right now, the cheapest way would be just to buy diesel oil and be happy. Anyhow, we started to look into this with alternative fuels. The alternative fuel that everybody was talking about was the LNG, liquefied natural gas. But that is natural gas that is freezed down to minus 163 degrees. And you could imagine to handle this all the way from the factory where they did that, which is somewhere close to the gas source, and then all the way into the ship engine. That is quite complicated. And when we looked into that and how much it would cost to make a conversion to liquefied natural gas for our ships, the thing is that our fleet is quite young. So and a ferry lasts for about 40 years. So it is not just to buy new ships. Maybe with cars you can, after 5 years, you can buy a new car. But when it comes to ships, you have it for 40 years, so you want to do something with the existing fleet. And then to convert it to natural gas or LNG, that would have costed about 35 million euro. So that is a really vast amount of money. And then we looked around in different projects and found that methanol was much easier to handle and so on. And there we could also, since it was easier to handle, we realized that it would probably be easier also to make a conversion. So that's how it all started with this. To do that, it's always good to have help from a friend or from many friends, and one is of course the European Union, because they also realize that this is a problem for the shipping industry. So therefore the European flag up in the corner there. And then we started a project, Methanol, the marine fuel of the future, together with Wärtsilä, which is a large engine manufacturer, and then our fuel supplier, which is our own company, actually, Stena Oil, and then the ports of Gothenburg and Port of Kiel, which is where this shipping line is going. Also, on the way here, we got a new partner on the way, and that was Methanex also, who joined in a little later in the project. So, in February last year, we took the ship out from operations and went down to the shipyard in Poland. It is the Remontowa shipyard in Gdansk. And there we did this conversion to methanol. And now I'm going to go in a little more technically to what we really were doing. But if you can look at the ship when it's leaving here, and the bridge is actually the bridge over the river in Göteborg, and you see the shipyard there. And then 40 days later, she came back again and went back in business after the conversion work there at the shipyard. She was not running at once on methanol, but we had done all the work that was needed to be done on a shipyard. And I hope you notice also the new painting on the ship, because as you understand, when we are doing investments like this, then of course the market people, they wonder what's going on, and then the market people, they made brochures and they repainted the ship and so on. So now it's super green sustainable shipping. And I will come back a little to that. I would say personally, I would have said it's enough to say green sustainable shipping. No, super green. But I will show you, and I think that's the reason why I'm here on Iceland right now, that we will, sooner or later, we will be super green also. So what did we do really? Well, it is quite down-to-earth technology. So we are adding a high-pressure common rail system to the engine. in parallel with the already existing fuel system. So we don't take the existing fuel system away. We still have that, and then we add one more system. And then, since it's a high-pressure common rail, we need high-pressure pumps. So we have a pump room where we have the high-pressure pumps. And then, of course, we have to store the methanol somewhere. And the good thing here is that we can store it in the double bottom. So we were actually taking one of the permanent ballast tanks that was in this ship, and we changed that to be a methanol tank. I will come back a little about how that is done. And then, since methanol is a low flashpoint fuel, and that means that we have to have a very special precautions, safety precautions, we are blanketing the tank on top of the liquid with nitrogen, so that there could not be any explosive fumes on top of the methanol. That is regulations that we have in the marine sector. And this is a little how it is spread out in the ship. So you can see to the left there, the engines, the 4 engines, 6 megawatts each. And then we have, I claim that we have the largest common rail system in the world, because actually the pump room is about 50 meters away from the engines. And then there we have this special pump room, which is gas tight, and everything inside there is explosion classed. The reason for that is that just in this particular room we don't have to have double wall piping. Otherwise we have double wall piping everywhere where the methanol is. So if the methanol pipe should have a crack or something, we have detection inside the next pipe, so to say. So this makes the whole system very, very safe. The engine, I mentioned we have this common rail system, and I would say that the real secret in the whole thing, that is actually this injector, the one on top on the left corner there, because that injector, it can handle 2 fuels. So it can handle both the diesel fuel that comes from the diesel system that we had from the beginning, and it can also handle the methanol. And that means that this is a real dual fuel engine. We can, while we are running the engine, choose exactly how much methanol do we want, how much diesel fuel do we want. And we always have a little dose of diesel fuel. I think we will get a little more knowledge about this later on. But this is, we need, since the methanol is an auto fuel, we heard about that before, we need to ignite it somehow. And we do like this, that we put in a little diesel first, like 5%, which ignites in the normal diesel process, and then we are injecting the methanol while it's already burning inside the cylinder. This is, of course, done in microseconds. And in this way, we can run a diesel process on methanol. This is developed, of course, by Wärtsilä, so it's Wärtsilä engines. The other parts that you can see there is the high-pressure pump, and also, since methanol is very low viscosity and doesn't lubricate at all, you need to lubricate the injector with some kind of system. And for that, we are using high-pressure oil, which is even a little higher pressure than the methanol, so that you have a sealing oil film, so to say. Oh, time is flying. So this is what the engine looked like before and after. And this is inside the new pump room, and the yellow blocks you can see there, that's actually the 4 high-pressure pumps. So there's 1 high-pressure pump for each engine. So what about regulations and safety and so on? Well, for the liquefied natural gas, there was a regulation that started to develop the IGF code, International Code of Safety for Ships Using Gases, but then it's important, or other low flashpoint fuels. But when they started with this, the LNG lobbying was so strong, so everybody just started focusing on LNG. And for the first 8 years, the LNG IGF code was developed. But that was actually ready last year. And then this work was chaired by the Norwegian authorities, and then it is within the IMO there is a correspondence group and working groups that is working with this. But now the chair has been taken over by the Swedish authorities, and we are very much involved in helping the Swedish authorities with our experience from the methanol on Stena Germanica, and we have done a lot of risk analysis and things there together with Lloyd's Register. And so now the regulations are on good way also for methanol and ethanol, and also for fuel cells. And we hope that it actually will be ready in September this year, and then probably next year it will be decided in the IMO. The classification societies, they have already prepared themselves, so they gave out those provisional rules and tentative rules in, well, you see the Lloyd there in 2015, and the DNV, they were even earlier in 2013. This, I will only take this part of the text, because this is actually the essence. Why is methanol good as a ship's fuel? And this is like poetry. We're not bound by bottom shell plating or fuel pump rooms. The tanks shall be surrounded by protective cofferdams. That actually means that you can have the methanol in the double bottom next to the bottom plating. You cannot have oil like that any longer in the new regulations. It's only methanol that you can store like that. And that means that methanol doesn't take any space whatsoever from cargo or anything else that you want to have in the ship. And then that it is surrounded with cofferdams and so on, that's no problem. It's just a good thing to have. So in our case, we have it surrounded with permanent ballast tanks, meaning that we have a tank with methanol down in the bottom, and then we have it surrounded with water tanks. So it's very safe to have it like that. And if we should have, for some reason, a leakage out into the ocean, nobody would ever find the methanol, because it is diluting in the water, as you know, and also biodegradable. So this is really the whole thing with the methanol. What about how do we get the methanol into the ship? Well, we have also, of course, prepared for bunkering stations at the ship. So and then so far we are taking the methanol to the ship with trucks, because we haven't really built up yet the infrastructure for methanol. When we have converted one more ship, we will probably bring it to the ship with a bunker ship or bunker vessel bunker barge it's called instead. But at the moment we have this, so we have in this container that you can see there, we have pumps, which is of course electric explosive classed and so on, and you can see that there is a sprinkler system over the truck and all those other. You can also see the concrete walls around the truck there, meaning that if you have a leakage, the methanol will stay there and you can take care of it. So, as a conclusion, after about 1,100 running hours on methanol, we have very few technical issues actually. There were some small leakages because the methanol, as I said, is very low viscosity. So the technicians, they were not used to this kind of sealings when they were used to oil before. We had some vibrations in the high pressure pipes, which were, I think, because of some miscalculation or no calculation. So we had to do that and make sure that this was fixed in a better way. And then also, since we have a lot of alarm systems, a lot of sensors everywhere, because we don't allow any methanol at all to come out in the atmosphere or outside the system, so to say. That has been quite delicate to adjust that system and fine-tune the system so that we don't get alarms all the time. But now we have managed with that very well. And the conclusion is that methanol works great as a marine fuel. I will just take the opportunity to say something about the future a little also. So as I said, the super green sustainable shipping. Well, this is a picture from the Swedish Shipowners Association's research agenda. And what this says is actually that to come down on the CO2 emissions to the levels that is we are supposed to come down to before 2030, that is 30% from, I think it was 2005. And we say that we can do that with known technology. We have already done it at Stena Line, actually. We are reducing our energy consumption with between 2 and 3% per year. So we have already done this. But to go on further to the zero vision that we all have in 2050, then we need some kind of technology bridge. And we believe that the methanol can help us to do this technology bridge. And that is, of course, the reason why we are here and looking at the Svartsengi plant. We saw that yesterday, and there are also other alternatives around in the world. Somebody mentioned, I think, earlier today, the NICM in Edmonton that is gasifying garbage and making methanol out of that. In Sweden, we have a project where we are taking the black liquor from the paper production and making methanol or DME out of that. And in Holland, they have this bio-MCN that is making biomethanol. So there are different ways of making green methanol. And of course, personally, I think that this electrofuel way that is happening here in Iceland is very, very interesting, of course, and exciting, because I mean, there's no limit for how much you could actually produce. I mean, the CO2 is everywhere. So what's next for Stena? Well, this is a study that we have on our drawing board right now. This is a ship that we call Stena Electra, and this is our hybrid ship. So the idea here is, of course, to use the modern electrical technology that is available, and also with combustion engines. So the idea is to come down to about half of the liquid fuel in combustion engines, and then use also shore power into batteries. And the good thing for this is that we are actually, ferries very often operates in cities. And in the cities, they want it to be quiet, they want it to be absolutely without any smoke and things like that. So the idea is that we can sneak in and sneak out on electricity and maneuver inside the port.